What can I choose? This problem E, free traffic lights. I think I did something here. What was that? I think I created some code, didn't fully work, I don't remember, but I started doing E, so maybe it's a good idea to finish it. And then NAND tree. Here I even have a submission. And this submission gets wrong answer on half of the tests. One possibility is to finish one of those, and I should finish them pretty soon, because otherwise I will forget everything about them. What is this? Permutation cover. I got some wrong answers, including the sample test. Again, I don't remember what's that about. I guess some heuristic, yeah, while true. The stuff. Maybe this problem then. Okay, I think this is fine. Then did they participate and just try to solve E? Or was it absolving? This is 3 hours later, which doesn't say a lot. That's 5 PM. I think that's the time of my stream. So maybe I just during a stream tried that. Not sure. Hi chat. Hello everybody. I think I will do this problem then. Why not? Replace Atcoder hard with Atcoder easy this day. Run commercials on a channel. I've just agreed to some strange things that I don't really want to happen. Anyway. Date of the contest is on upper left. Alright, thank you. Ahmed, you're right. This is 20th of June and my submissions are from December. Then it's clear I didn't participate. We're solving this problem. We're given info how many times every element appears. And permutations on 1 through k appear everywhere. Okay. Some people solved it. What's the title? I'm modifying the stream title. Actually, what's the point? Okay. Does this always exist? This is the first question. If there aren't big discrepancies between numbers, also, do I want to think about this from scratch if I did that in the past? Or should I already start from the editorial? I have very bad memory, and if I tried solving this problem half a year ago, I will likely go through similar steps. It's not really that I will continue when I left off. You read every problem like you memorized it in the previous day? What do you mean, the statement? Channel, come on, stop. Well, let's call it, we can call it E, I guess. That's code from Code Forces, but I will use it as my notes. Also, I'm annoyed by this. I don't want new star to appear when I hit enter. Where will that be? This? Yep, but cool. The first test, twice there's number 1, 4 times there's number 2, and 3 times there is number 3. We try to put 1 on the first position. The whole thing will be of length 9. And we need to check if it's possible to finish this sequence if I put 1 here. No. Maybe even without just putting 1 here. Is it possible to here put all those values, to permute them in proper way? Well, the first 3 numbers, they need to be a permutation to make this part of some permutation. Then conditions for those are satisfied, and then this guy is part of some permutation. In particular, we can use 1 through k like that, or we can create some common part. When does it make sense to create a common part? When some number appears fewer times than other numbers. Maybe it makes sense because 1 appears fewer times. Maybe it makes sense to put 1 here. And then 2 and 3 will be there, 2 and 3 will be there. And then I can either continue from here, or maybe I can also say that this is a common part. But why would I do it instead of just putting it here next to this guy? Where do I work? Right here. Let's say that streaming is also part of my work. Actually, it isn't. I don't get paid. Though I'm going to change that. I need to reach to some companies to ask them to pay me at least like $100 for such a stream. To really make this my source of income. Does it make any sense to say that now 3 is a common part? An alternative is that 3 was already here as the common part. So I'm doing this. 2 appears twice, 1 and 3 they appear once. So this way with first 4 elements I count for a difference of 1 between frequencies of 2 and 3, 1. What happens here? It seems that with the first a lot of elements I do that. So this is better. Jane Street sponsors math content creators. I didn't know that. Can you show me some examples? If Jane Street wants to sponsor me partially, I would be happy to do that. Or maybe IMTech. That would be even better because I worked for them. I don't know. They want to spend money though on such marketing. Okay, but Stand Up Maths on YouTube is a huge channel. He's like, what, 100 times bigger than I am? And what was exactly the collaboration? Maybe not 100 times bigger, but more than 10 times bigger. And the Jane Street is looking for mathematicians, I guess, more than programmers. But I think in my audience also there will be people who are proper candidates. Yeah, I think I should reach to such companies like IMTech or Jane Street. I need to later watch this video and see what was the the ad for Jane Street. That's a good idea. Which problem I'm solving? This thing, permutation cover. The strategy I will use first is to just say if something is possible. Look at element with smallest frequency. If there are multiple such elements, let's say that the input is 5 and then 2, 4, 3, 2, 2. Then elements with smallest frequency are 1, 4, 5. And I will make them common for first two permutations, and the remaining 2, 3 are here and there. And this is such, say, double permutation, where 1, 4, 5 is the common part, and this way the remaining frequencies are a bit closer. What's left is to handle 5 and 1, 2, 1, 1, 1. Yeah, that's what's left to handle. Also, it implies that the answer is impossible only if some frequency exceeds another twice. This is possible because maximum versus minimum, the difference is at most 2. The ratio is at most 2. Alright, then what's the solution to the problem? We need to find lexicographically smallest. So we need to put something on the first position, like 1, and then continue the sequence. In particular, if I can say 1, 2, 3, 4, 5, and then split and continue, if that works, great. If not, it means that there is some element that is too frequent and some element with too small frequency. But in particular, here I could repeat 1 and 2. But also, it's a big assumption that it's enough to handle such double permutations, where, for example, this is a permutation of numbers 1 and 5, and then another permutation with some common part in the middle. It looked reasonable here that this is enough, and it's not that I need to have 3 consecutive permutations, each with some intersection. I'm doing this, and then everything with too big frequency I'm trying to add here. That would be the strategy. It cannot be all of 2, 3, 4, 5. And always when I already created some elements, for now without repetitions, then I know that there will be remaining elements here, let's say I and j. Then here I can add something more. But those must be in particular x, y, and z in this order. It's not that I can here put y without z. I mean y without x. What am I saying? This is valid, but replacing x with y would be invalid. This is valid, this is valid, this is valid. Why is now this invalid? Because this is a bad permutation. No, this is valid. Can I even do this? And then this must be a good permutation, so we have a split right here. Ethical hacking. No, I'm not into security. No, the more you specialize, the better you will be at that single topic. And I specialized heavily. I went into competitive programming, the algorithms, let's say single-threaded algorithms, not all the parallel computing, and I'm quite good here at this stuff. What about crypto? I don't know a lot about crypto. I don't really read those white papers, so I'm not an expert at hacking or crypto. And I don't even know if you ask about cryptocurrencies or cryptography. Machine learning, neither. Actually, I worked in machine learning for a few months as an intern, but it was very intern-like job. I didn't do stuff, I learned and only learned. It's more like my job was supervised learning, and I'm not talking about ML algorithm, I'm talking about what my position was. I was learning under supervision. The strategy is if I put XYZ here, then I know there must be some I and J to follow. And then I'm putting here most frequent elements. In particular, I can put X, Y, Z. Can I put Z here? No, I can't. In this order, X, Y, Z, and then in some order, I and J can be there as well. And either that works or not. That's my idea. But then I guess that I tried that also during the contest. So let's see the prefix of editorial to see if it should be like this or something else. I'm looking so quickly because I already spent time on this problem in the past. I just don't remember exactly what I did. In a single step, you can subtract 1 or 2 from frequency. That's right, with some conditions. Because I also minimize lexicographically, so it's more like if there is XYZ as prefix of the sequence, I need to just make a check whether I can finish the sequence. If yes, then this is a good prefix. there exists a sequence satisfying the condition if and only if maximum element is at most twice the minimum. Alright. Well, they have some crazy conditions. It's not really what I did. Maybe I should... If I just read this, the whole thing, I will know a solution, sure, but that's not the point. My submissions. Did I do something similar to what I have here? One to 4, then 3, 5, then 1 to 4. This is exactly that. In kind of infinite while loop, or just we try forever until we reach the goal. I try every value from 0 to k minus 1. Not used yet, then I try to use it. What would be your thought process if it would have been a problem from ongoing contest? There are hundreds of screencasts. I solved hundreds of problems, live and not live, just recorded, so you know plenty of my thought process during a contest. If you want to know, I don't know what to say. My thought process during a contest doesn't differ that much. Let's try to specify the rules here exactly. We consider the prefix. No, but I don't know if those are enough, and I don't know that from editorial either. I can check that with brute force partially. This is a very random, I mean, easy condition, but it's different again from my solution. I don't want to implement something I already implemented. Last time I got wrong answer, found the test where it failed, then realized the solution is wrong. Damn it. So this is wrong, and I'm able to believe that. Maybe we need to intersect 3 permutations, not just work like this with parts of size at most 2, like 2 intersected permutations. especially because not only we say impossible or not, but we need to finish some partially started sequence. I sometimes don't absolve. What do you mean? I'm absolving right now. Okay, then I'm not implementing this idea, if I already did that half a year ago, and instead we need to go with their idea. They said something here, I've already read it. Then my job will be at least to understand it without reading the rest of that editorial. They say that it can happen that maximum is twice minimum plus 1. For the whole sequence, if some element appears 5 times and some other element appears 11 times, that's bad, and you say impossible. But after you did some prefix, then if you still need 11 B's, it's fine if you can put B before A, it seems. You already did some prefix. Now, very soon you want to put B, and only later you want to put A, and then no. So this is not enough. Before we go with this pattern, BAB, we need to finish something with one more B. So it seems that in this already started prefix, there should be B before A, and that's it. And there should be no repetition here. Because if there is repetition here, like CC, then we need to write here start a new permutation. So we cannot use this C. So this part, this thing, it should contain distinct elements. And then indeed, if this is the prefix already done, and the remaining frequencies are like that, what we require is that the last A is to the right of the last B, and to the right of this A, there are no repetitions. This is if there is a unique pair, such that one is more than twice more frequent than the other, and the difference can be only 1. If this is 12 or bigger, then the answer is impossible completely. Let's see if they agree. Every I such that there is X. Okay, this is very different from what I said. Top 5 languages: C++, Java, Python, and the others are like less than 0.1% of people in the top. What am I solving? This problem. How tall? 191. Let's see an example where this doesn't hold. BAB BA. And now we need to continue. I want to put 11 B's and 5 A's. this sequence, this prefix, it satisfies conditions from the statement. What is Q? And they mix with each other, so this condition is not true. Yes, Python is slow, but it doesn't matter if you're a beginner. What don't I understand? Time limit same for all languages? Depends. It depends. Depends on the context. Some platforms have their multiplayers, some do not. They say that if x is bigger, then all x's must be to the left. Here all b's must be to the left of all a's. What means Camille? It's a name. Facing issue getting some solution over internet? I have no idea what you mean, but CSES problems on purpose, they don't have editorials, and you're supposed to think about the solution yourself. If you want to solve problems with editorials, go to Codeforces or Atcoder or CodeChef. Do I understand the problem correctly? I'm reading everything here, and still I disagree about this, and I think that line 38 on the right is a counterexample. If you see my mistake, please explain it to me. And this is very common, that I spend a lot of time just looking at the editorial and spending a lot of time understanding it. Which part do you think is wrong? This one. This is a counterexample, where I can finish it, but it doesn't satisfy this condition. Purple is hard to see. Is it? It's actually pink rather than purple. The default color in Genie is gray, light gray, and I think it's worse than pink. Java, don't ask questions unrelated to the stream. If it was some kind of Q&A, then sure, you can ask. Let's say stupid questions, including this one. Stupid meaning, yeah, sure. If you know the answer, please tell me. Sequence looks fine. The point is that now this sequence doesn't satisfy this condition, and yet I'm able to here put more than twice more B's than A's. If I need to still add that many A's and B's, I can do it here. But they say it's possible to finish a sequence only if this condition is true. But the condition is not true for this sequence, and yet I can finish this sequence. Thanks, Fenwick. Please, somebody explain this thing to me. Maybe they meant the last such I. How can it matter if I even add, let's say, just A, B, C, D at the beginning, and then I continue from scratch? Question is the last two terms, A, B, which satisfies... I'm trying to understand the post by Chessmaster. Last two terms AB, which satisfies... Oh, Q is this. What do you mean by A and then in brackets frequency 5 of remaining? I don't get your English. Or maybe they mean the last B and the last A. After BAB you can fit 5A, 11B. No, that's not true, but after BAB, BA, this thing, after that I can fit 5A's, 11B's. Or just 1B. No? If I have this string and I need to add one more character, I can add character B. But then frequencies, they don't satisfy that. I mean, they satisfy x is equal to twice y plus 1. And then they say everything of type x must be before everything of type y. What do they mean? Do we want few occurrences in a row of this? There can be only one occurrence before occurrences of another type. I think that this sentence is just wrong. Really, you didn't want to work in Google. Why should I? Translator says the same. They publish editorials in both Japanese and English. I'm so confused. Should I ask somebody about this? Who's the author? Maybe I know the author. Not personally. I'm looking for anything about E. Didn't find any. Maybe it's not true that we start building the sequence from the left. Q is just the one permutation, not the whole sequence. The last k terms in P form a permutation. Let Q be this permutation. So they do not build sequence from left to right, at least not right now. So we built it from the right. Yeah, Q is the last k elements indeed. So I shouldn't look at this, I should look just at the whole sequence and then say the last k elements, this is Q. It apparently gives me some kind of order. Just stretching a little bit. X, Y are indeed AB in some order. Now this doesn't matter anymore because they didn't say that they build a sequence from the left. I don't know what they are doing. I would also assume that they built from the left. So what they go from the left and they do something like 3, 6, 2, and they need to now choose the next element. And then at the end there will be the last Q element, the last K elements. And we care a lot about order of stuff there. Minimum elements should be before the maximum elements in the last k elements. No, that's not counterintuitive. If we want something to be really, let's say we want B to appear a lot, then we will mainly repeat this pattern. So in the last elements without repetitions here, the maximum is indeed to the right from minimum. When you keep building, when you're at any moment, like here, it's fine that in the, like you need to still use more B's than A's, or more than twice more B's than A's, assuming that you finish with B rather than A. Oh, in this situation is impossible because right here you would say that there are too many B's. So we automatically take care of that. B. Oh, I see. So there is no way to mess this up. You will be forced to use B, then use B, and so on. But what do we then say that at the end we will have A and then B? How do we go about it? I keep some kind of graph, directed graph of dependencies to say what should happen at the end. Maybe. Would be very strange. So then you just don't want any cycle in the last k elements. The code will be just this for every position from 0 to n minus 1, len minus 1, for every value from 1 to k. Try this value here. If now twice frequency of one element is, no, if frequency of b is now twice frequency of a plus 1 among remaining elements, then there is edge from a to b. Yeah, from a to b. And this function, it should check if already that would create a cycle. That's some forbidden dependency in the final k steps. Alright, and if I is among the last k positions, then also we should respect the edges. Never we can, among last k elements, we can use something where still there is an edge from unused value to this one. That's very clever, but also I feel that they are describing something else than I did here. Did they say anything about those directed edges? Minimum number of characters we need to add? Last k elements are just a topological sort of the graph. Not only that, it's the lexicographically smallest topological sort of the graph. And also, as we go with the first len minus k elements, so maybe first we do this, and lex smallest topo sort of the graph. That's the last k elements. But instead of running topo sort algorithm, I will do it slowly because constraints are low. So I will use something similar to this. And here edge is maybe consider edge. Consider if would create cycle, then bed. Anything else? Oh, that's just it. And if doesn't create a cycle, then we indeed use this value. If creates a cycle, then we try another value. Atcoder problems are crazy. I will implement it. Maybe while implementing, I will understand some other issues. Here actually I check two things. One is whether there will be some pair with 2 bed frequency, because only if twice frequency of one element plus 1 if this is equal to frequency of y, then we have an edge. All right. here in the middle we try stuff. For every other value, if frequency of my value is greater than his, or the other way around, this is bad. But also I checked if there is for sure contradiction. Now need to do the same and check if there is equality. And then I put edges. Where's twice? That should say twice. If I'm more frequent, then I need to be later. So it's like this. This is a direct edge. This is never true if v is equal to value, so that's not an issue. And what we have, directed edges. What's the easiest way to check if there is a cycle? Do I need to use DFS? Also, what's the complexity? L times iterate over value. L is 1000, value is 100, and it's bad if the graph has 100 square elements, but not that bad. I guess I will simulate toposort here. Or maybe I should just focus on values that I add right here. There is some DAG and I consider adding new edges. I need to say if those edges create a contradiction. I think it's not easy. I need to go through the whole graph. Right, then going through the whole graph. Add edge v value. Always if something has input degree of 0, then I will continue DFSing from it. Like that. If input of a is 0, then do that. Looks reasonable. But first I need to initialize the input values. They should be 0 first. Right, like this. Then run the DFSs. And if somebody's input is not 0, then OK is false. If not OK, then continue. But also we need to recreate stuff. So first this, and then this is how we added edges. Same way we can remove them. But if okay, then what? Attach actually isn't a complicated function, it's just this. That's too few numbers. Oh, overwritten. Because I don't handle the last. Okay, so the first elements, do they match? No, this should be free. 2, 1, 3. What's the issue with using here 2? Well, the issue is this is not a permutation. That's actually a very important condition. Indeed, element 2 appears so many times. Should I just check that element k is to the right? Right now, if I, which is of course very stupid, if I just said, let's say 5, and then 3, 3, 3, 3, 3, I think I will have 2 1s at the beginning. Exactly, there are 2 1s. That's not something we want. So what then? We put conditions about what was used so far. Maybe this is part of editorial that isn't really described well, but I kind of skipped it. Topological sort. When you see a vertex that can be first in topo sort, you make it first in topo sort. That's it. That's the idea. We can check if there are contradictions already. For the first k elements, there cannot be repetitions. And then always when adding a new element, it's actually crazy that this will work. First k elements need to be different. Then when adding a new element, if we see if there is any contradiction already. Right here, what do we check? Also, there can be 3 equal elements in a row. For every passed element, I need to check if theoretically it can be in proper permutation. First, let's do that quite slowly. Can the issue caused by adding this value only be with equal values? So if I already added something, and then let's look at the last three. Now I'm considering that maybe I'm adding this new three. The issue will be with this guy. So is it enough to check if this 3 is part of something? Looks that way. It can be like that, can be like this. Yeah, that's a good idea. So find the previous occurrence of value. Check if it already is in some permutation. How do we check that? For every possible start, we just consider k consecutive elements. Start plus j. If I found the match, stop searching. If not match, then okay, it's false. How can I hear? I don't push back anything to answer. And when I say that, yes, this value is added to this. And now I added too few values. Why? Something is clearly wrong. I should be able to add another one here. So maybe my check is invalid? If because of this mismatch something, oh, I didn't copy paste my debug. Sure, I value and how many elements in answer. 1 wasn't good. Why? Okay, this for sure is wrong. Should the answer that? Okay, I'm checking. Answer, obviously. Yeah. I used indices instead of values. Still wrong. But I need to just be more careful about this. Start plus J. Why is this start? Is that even Z? Here we go. 213, 223. It works here. Let's check other tests. Everything other than the last K characters should match. No, I didn't copy. I didn't copy the input. 3413, correct. I guess I should detect situations where it's -1. So I shouldn't print here. This prints -1 because I don't finish with the topo sort. This has some repetitions then. I'm just modifying this code to also find the topo sort, not just check if there is no contradiction. Maybe like this. Normally don't find the order, otherwise please do. Ugly copy paste. Not order, answer, so just nope, 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 nope. One, two, three, four. Not good. I'm not finding lexicographically smallest topo sort, I'm finding any topo sort. Won't this just magically work for the very end as well? It will. Because if it is done at the end with something, then its frequency is 0, something else has frequency 1, so I know what needs to be before what. Yep, so if that's the case, I just don't need this. Didn't quite work. The only way I know is this. I wanted to do it just brutally, you know. Always at every spot I consider every possible value and I see if its input degree is 0. We don't need priority queue. But now I don't know why this is wrong. So we're putting 1, and then 2 and 3 don't follow. If I'm bigger, to be later. One has all those edges. I don't see any contradiction here. Unless multi-edges are an issue? They shouldn't be. Statically typed language like C++. C++ in Java are faster than JavaScript and Ruby, so in competitive programming, C++ is better, or Java. The edges right now are fine, assuming that I don't have troubles with multi-edges. But I think that's not an issue. Then when I consider value 2, what will happen? Also, just to make sure that I'm not messing up. The remaining frequencies are 0, 1, 1. That's fine. This is how it should be. We get here. We get here as well. We are here, and then OK depends on this thing. This is a valid graph. So is there a mistake here in checking if graph is a DAG? From 2 to 3, from 1 to those. -1. Somebody's input degree is -1. Don't we call DFS2 twice? You're right. You're right, I messed up here. I messed up topo sort. Here we go. Thank you, the real KR stuff, for help. 1, 2, 4, 3, 1, 2, 4, 3. And this should now say -1. What's the complexity? 1000 times 100. This part, I believe this is at most 100, and then this is at most 100. It seems that this part, wait. Oh, but this happens only once, so this for loop is irrelevant. And we have 1000, 100, 100, 100. 1 billion in total. But also this track is very easy. I know. When adding a new value, I will check if the last k values are distinct. Then for all of them, we mark them as in permutation. There will be such Boolean sequence. Shadowed something. And let's use J. No, this first part is for sure fast, right? How can it be? 3 for loops, one inside the other. What I added is very fast. And then what else I have? 1000 times 100 times 100 multiple times. And the most important thing is topo sort. It would be nice to get rid of multiple edges, I would say. I can index iterators? Yes, I can. That's indeed very surprising. You see, this is an iterator. When you use array A and you type this just means that you get pointer A and you increase it by 5. So any kind of iterator, you can do this with any kind of iterator, including end. So let's say that now there is a vector v. This is an iterator, just like find will give you an iterator, and then you can use negative stuff. So yeah, that's a very nice way to get in C++ minus j, so j from the end element of the sequence. Cool stuff. Favorite tag in CP? Probability maybe? Google Coding interview? Not today for sure, I'm busy. There is a way when adding a new edge to check if that would create a cycle. When I add edge from A to B, I should just, a moment ago, run DFS from B and check if I can get to A. But, well, this is still DFS, so it's complexity linear of size of the graph. When adding edges, when I see here finally that, yes, I value. Let's get rid of repetitions. Maybe then it's a little bit faster. This will be repeated 1000 times, so it's not an issue, I think, that I keep doing that. Oh, what did I do? Let's see. If I get time limit exceeded, I will keep improving. Right now, I'd say the complexity is still bad. It's like 1 billion. It's 1000 times 100 cubic. Maybe it's better than this. I don't know if that's complex. If that complexity is really triggered exactly. I can bookmark it. It's hard for me to follow all the suggestions. If you have a suggestion, put it in YouTube comments or in Discord server. Well, it's fast because it's not necessarily, it doesn't necessarily take all the time. I don't know. Is it suspicious? Depends a lot on this part. Often, okay, very often something will be discarded by this, And if this condition actually allows some number, then maybe very often this number is indeed good. Maybe the complexity is better than we think. Maybe, of course, also tests are weak. And maybe that's suspicious. It should be suspicious, and I have a mistake that actually causes my program to be fast. What can we do now? Well, we can try a few tests. Let's see what are the small tests possible here. Values are from 1. Doesn't help that it's hard for me to verify if something is good or not. Can you send submission link? I can. Are submission links public? Oh. Chat below the face is very distracting. I mean, you can take a piece of paper and tape it on your screen. I think that chat isn't that distracting, so this is why I keep it. Of course, I can hide the chat because I can do this, but I don't think that chat is that distracting. It's better to keep it. Especially because later people rewatch the stream. Some people cannot watch it on Twitch, and they need this, I mean, to see the comments at all, right, on YouTube. So to you, I can only recommend putting a piece of paper on your screen. All right, then I will do what I often do because I'm lazy. No, it restarted. How do I get the whole code? Is there is copy button. Before I what's the ignore white space command? Okay, this. Before I write a generator for random tests, chat, you can give me some tests. The sequence is enough, so ignore the n. Just tell me what to put here. There should exist small tests where I fail, because I already failed on test 1, like the first after samples, and the time was small. So I think we can hit something for n being 3 or 4. Yeah, the solution is unique indeed. Last chance to give me tests. Why there's no gen? Why am I in directory B? Hi, Yusuf. What is happening? Oh, here we go. Is that... Oh, again, it's about white spaces. I didn't expect that. What now? Let's see what my program actually finds. It puts here a 1. Don't tell me that this is completely wrong. The frequencies become, then after this one, 1, 3, and 1. So 2 must be at the end. The next element here, it would need to be, what, 2 again? Yes, 2 again. My solution is completely wrong. Another day, another failed Atcoder problem. It's wrong that I'm putting 1 here, even though for frequencies it's fine. For this graph of dependencies it's fine, there is no contradiction, but it's just impossible to finish this. I didn't fully follow the editorial. The editorial mentions using few numbers and choosing lexicographically smallest option. I go with numbers 1 by 1, and I thought that it's enough. I didn't want to exactly implement what editorial says. I thought that I understand this. At least my program is fast. I guess that often it just finishes and says, well, impossible, I'm done. So Is it really true that this can be finished? Is it? It's true if the current prefix satisfies the condition that every element appears in something, and if prefix is that, then this one is not satisfied. Apparently, if I start another one here, I would need to finish with some permutation of 1, 2, 3, and only then check the condition. Maybe I should then consider, okay, there is 1, I can finish with 2 and 3. Look at frequencies then, see if there is contradiction. What is a good way for a beginner to get into competitive programming? I would normally say that you should watch my video how to start with competitive programming. But if you're really crazy, what you can do is you can solve Atcoder grant contests, like the one I'm solving right now. But you need to be insane for that to work. All right. Right here, what I will do is, if I'm not part of a permutation already, then I iterate over where I will finish with my permutation. But then should it matter what's the order of those elements? It should matter. Right now, I think that we need something like this. Let's say we're adding number 3, case 5. Then I should consider that maybe if 3 isn't already part of permutation, like this, then maybe this should be a permutation of numbers 1 through 5. So just check if this is possible. If yes, then you know what to put here. If not, maybe this. Then there are some 2 elements, x and y, that we need to put there in some order to make this into a permutation. Let's say that, yeah, this can be a permutation, and we figure out what is x and y. We don't know the order between them. Then we run our checks for frequencies. And so not only I decrease the frequency of value by 1, but also frequency of those, x and y. Then do stuff, we check, and if everything is alright, then I leave 3 right here. Alright, let's do this. That's some hope. I have some hope that this will work. I didn't push back to answer yet. So answer finishes here. -1 minus k. So I can check this, +1. What if k is 1? I think I should just temporarily add to the answer. It will be easier. We need to remember to roll back this change. for every start. No, I is used. J. So for the whole suffix, mark it as used. Like this. The suffix is marked. I checked also if there are repetitions. If there are repetitions, continue. Otherwise, this is some candidate. Also later I'll need to roll back the change with answer. Everything not used. Temporarily I should add to the answer. I can also just do this. And frequency of the value itself. And now I can check the conditions maybe. Start shouldn't become equal to answer size. You're right, thank you. Now check the conditions. And then do the rollback. An easier way to roll back will be, is frequency a vector? It is. Here I will roll back with single operation. Well, it's linear, but still, it's easier to code frequency is memo frequency, instead of iterating again. So we check this, then all right. I will be lost here in this code, so check if suffix doesn't have repetitions. Maybe let's number the steps. Decrease by 1, so decrement frequencies in the suffix. Not in the suffix, in the of numbers not from suffix. Check if frequency of A is greater than frequency of B times 2 plus 1. See edges with equality. Check for cycles. We also need to roll back edges. Continue or break here? Continue, what does it refer to? To the next start? Okay. And finally here, this is step 6. Yes, add this value. That is false. This says whether it indeed happened. The edges are added, right? And now I'm lost. This thing, where does it start? Here. For every suffix. So after indeed we should break, then we break from this. Okay, we break from this. All right, okay is true. Here we have some internal okay is true. That didn't went too well. When we add 1 first, that should be bad because of frequencies. Well, the issue is that not only I put 1 here, but I also imagine putting 2 and 3. So because of that, I think that 1, 2, 3 is good. Right? Then the remaining frequencies are 1, 3, 2, and my program thinks that this is possible to handle. So should I look at edges after everything is added? Or only here? Or maybe in both? Here's the thing. When I start with empty string, this is the input. I start with empty sequence, then I consider adding maybe 1 at the beginning. The question is whether now I should care about those edges implied in the final permutation, or I should say that in some order there should be now 2 and 3, and now let's look at the remaining frequencies and let's see the conditions. Previously I did just this. I thought it's easy to see when we are just after 1, because then the remaining frequency of 1 is 1 and the remaining frequency of 2 is 4. That's not good. But they said that those conditions are needed only when we have a sequence where everything is in some permutation. I don't understand what they are doing. Here we need the X appears earlier in queue thing. Yeah, but the question is, do we need it here after adding 1, or after when we add 1 we say that we need to finish that with 2 and 3, and I do that. When I focus on this, just say, okay, after 1 I care about frequencies. I implemented this first and that's wrong. Now I'm checking that after 1 to 3. And my program thinks that it's correct to start the sequence for this input. My program starts the sequence with 1 to 3. It thinks everything is alright. After 1 to 3, the remaining frequencies are 1, 3, 2, the frequencies. And they satisfy all the conditions. They will just put 1 extra edge, so no worries. And yeah, that's bad. Also, I don't like the fact that this, I actually don't add edges. I have a mistake, but still, like logically, if I understand my program correctly, it will start with this sequence. Okay, the real, I will analyze what you said later, but I see what I'm missing in code. Still, I think the logic is wrong. If indeed added. Am I right to say that everything is empty? No, I'm not right to say that. When do I cancel? I should cancel in both cases. And here I don't even check Eric. All right, Eric. Frequencies, right? Oh, but here I'm just checking things with being pairs with value, while I a moment ago modified frequencies with a lot of things. So this check is wrong, this check is wrong. But this check will be enough, and this is something I don't want to roll back. Edges of A is bigger. It will be later. Even better. Okay, rem count is 1, 3, and something. Yes, I agree. X needs to be before Y in Q, but here's the thing. If we start this sequence with 1, we cannot finish it. 1 is not a good first element, because then just after 1, am I right here? Maybe actually I'm not right. Let's think. For this, I claim that we cannot start with 1, because then you need 3 2s, not 4 2s. It would need to be like this, and with some 3s. It's not correct to start with a 1. And this is why I think it's not correct to, when considering starting with 1, to just say, oh, I will put 2 and 3 here. Because putting this 1 can already be wrong. Then I can additionally check here what's the situation. Two hours already I'm working on this problem with editorial. Now I'm making a hack where after adding 1, well, that's not intended. We should start with 2, right? Why am I not even adding that 2? Maybe I didn't clear something. What's global? Frequencies, for example. Wait, I don't get to that state. Yeah, I'm not even here, so I have a break, I think. Why is there a break there? Break should be here. There is a 2, and then there is no 1. Let's see what's going on when I am at 1 and the value is 1. One, two, two. That shouldn't be 1 to 2, should it? Twice I decreased the frequency. The same thing. Where do I retrieve here? This means nothing, really. Like, I'm passing the first test, great. I just added a hack. So. Well, I want that. Obviously, fingers crossed, maybe this works. This was the counter test? I think so. Now I update frequency correctly after adding an element. Previously I didn't. But I have a very strange solution where if I have some prefix and now I add an element x, what I do is I check two things. I check if now there is some contradiction after adding x, and I try to here add some suffix to make this something here to be a permutation, and I check if after that there are no contradictions. Two seconds time limit. I have 99% of that. I think that my solution is hacky and wrong. I will take it. I don't know. My solution is now like 100 times slower than previously because for various suffixes I check something. I don't know if I could make this faster. Maybe. Write-ups for CSES. Whatever you will find in Google and Codeforces. Big W. You know, on one hand, it's nice to see this red accepted after 2 hours of solving a problem. On the other, I feel like a student who, during an exam or even during a class, he did some random stuff they didn't understand, like this approach, oh, didn't work. I got some non-integer answer at the end, and the test is ABCD, I didn't see, like, it was none of them. I did another way, then I got a hint from teacher. I did another way, something worked, and finally I got the right answer, but then I will not be able to explain to anybody why this works. Still unsure about the edges stuff. Every edge, it is information that in the final permutation, the rightmost permutation, something needs to be before something else. So those are edges for topological sort, or in other words, there cannot be cycles, because a cycle means like dependency like A before B, B before C, C before A. So I just need to check if if directed graph doesn't have cycles, so it's DAG, directed acyclic graph. And as I said, when I add now X, I check if now there is some contradiction, and I check if I can finish here some permutation to make X be part of permutation, and maybe now there would be some contradictions. Ever struggled in technical subject? I mean, if something is very difficult, then sure I will struggle. University of Warsaw was very difficult. Some subjects were really hard to understand. You need to spend a lot of evenings. For example, when you study math in a good university, you need to think and practice a lot. If you can't explain it, you didn't solve it. I agree. I agree with that. I would say that to my students for sure. So, you know, if in this table I could mark stuff, because I solved, I think, this, I should mark this as to do understand later. That being said, I already see that right now I don't understand it. Editorial is not enough for me, and I would need to talk with somebody else about it. Maybe this is something where I should get paid private classes with somebody better than me, where now we would spend half an hour and we would talk about my solution, and I would want to understand this. Okay. Well, this is, I think, like one of 50 hardest problems that I still need to solve. So it's some progress, say 2% of the progress. Tourist can teach me. I don't know. I don't know if he wants. I didn't hear about any paid classes given by Tourist. You can explain the editorial? Okay, so tell me how they build the sequence. They build from left to right and they add one element at a time or multiple elements? I assume that it's multiple elements, but then what about this test? Their input is 3, 2, 4, 3. And then if you add at the same time 1, 2, 3, and now you look at frequencies, you will think that everything is okay, but the fact that here you started with 1 is wrong, and you will not be able to finish this. So if we add multiple, explain to me how is it possible that we're not adding 1, 2, 3? Because after 1, 2, 3, frequencies are fine, and there is no contradiction. By the last condition you mean this, or something here lower? Is this the last condition? This the thing I said before? Yeah, but oh wait. Q, I've always thought that Q refers to this thing that will be to the right. By Q, I thought that Q is always here. So I'm working on the left, I keep going, and always this is Q. Are you saying that always Q is the currently created permutation? So right now this is the current Q? Okay. I see. Then it's interesting how much I misunderstood the editorial. I see some similarities and I see a hope that my current solution is indeed correct, though overcomplicated. There is some monotonicity going on, or on what elements are better to be put first, but let's not think about it. And now if I have 1, 2, 3, I will try to here put some elements, maybe 1, maybe 2, maybe 3, I guess, and then this will be the Q. And I know frequencies after, because I know that those must be elements 1 and 2. This gives me some conditions, and thanks to these conditions I can know what's the top sorter. I can know if this can be 1. Yeah, okay, thank you. I understand a lot better than I understood 5 minutes ago. I wonder if the editorial is badly written, or I'm the stupid one here. Or maybe both. That's also a possibility. So we start from, I guess, empty sequence P, and we keep building it, always satisfying the fact that this marked thing, and always we add a few elements, which are part of the permutation, which is a suffix of the whole thing. Yeah, now I understand the idea. Always blame the editorial or tests. When you get wrong answer, you can also blame tests. Oh, tests are wrong. Which actually happens in contests. When, I remember situations like this. When we were the strongest team, for example, say in some kind of regional team contest, we were the strongest team and we got wrong answer on some problem, there was always this thought at the back of your head, oh, maybe it's not my fault, maybe it's organizers. Because you know that you're actually stronger than organizers. Organizers aren't that experienced. You know better, so yeah, likely it's their fault. Yes, they have a lot more time to prepare stuff and they should write brute force stress test, but still it's that thought. And it makes sense. Often we got that. So wrong answer, blame tests. Can't absolve, blame editorial. Wrong test data in a problem. Yeah, I remember one Polish team contest where half of problems were wrong. Like checker was wrong, input data was wrong, the intended solution, so output data was wrong. Those are 3 different problems. Issues with precision on doubles, like real values. 5th, I don't even know. Out of 11 problems, 5 or 6 were just wrong. There were big issues with them. That was very frustrating. Oh, I also remember one more where you needed to, this was an interactive problem, you needed to win against opponent who uses predetermined strategy in, say, checkers, but they didn't follow that strategy. There were cases where they did something else. And we learned about that after the contest, when organizers showed us a test and this simulation where we failed. And we said, hey, your bot doesn't behave like it should be. Close not to qualifying toward finals. If you're the strongest team and it's some kind of regionals, then you should keep in mind that one problem can be faulty and you should switch to other problems. Not everybody should focus on one problem. You should keep that in mind. In, let's say, finals of ICPC, I would assume that everything is well prepared. But in such regionals, this assumption can be deadly. Anyway, problem solved. Next time maybe I will try F. What's F? Forbidden what? Forbidden tournament. Some graph counting problem. Was it solved by anybody? Yes, by a few people. Difficulty should be similar to E then. Then next time, and that might be in 2 days, maybe this Thursday, I will try to solve this problem. If you want to, then next Atcoder stream, if you want to already know the problem, then it's this thing. Next Atcoder stream, we will solve F from the same contest. Lockout competition in the summer. Now I'm practicing before Google Code Jam, so I want to solve hard problems. Some people stopped code forces. Who did? I don't know anybody who stopped code forces and is doing Atcoder. Okay. Quick look if maybe somebody is streaming on code forces. Nope. Here's a hack for you if you want to stream competitive programming. You can stream after me. Just put your stream in code forces and then I will raid you. Was that the name? Raiding? Raid, yeah. LHIC? Well, Atcoder is very interesting. Those are interesting hard problems. Atcoder is tailored for strong competitors. It's better to participate there. It's more interesting and beneficial. Learning data structures in the summer? Yeah, that's a good idea. All right, y'all. Thank you for watching. Join the Discord server. See